Hello and welcome to the lucky 7th installment of Kerbal Space Program with the ARC. Last episode we left off having unlocked the heavy rocketry tech, giving us access to larger and more powerful rocket engines, and I think today is finally the day we are going to send our first Kerbals on a mission to a new world. The larger engines, as well as the larger fuel tanks we unlocked before that, should be enough to build a vessel capable of landing Kerbals on Minmus. Let's set to work seeing what kind of craft we can design. A big consideration for a mission like this is where the science is going to be coming from. Unlike our unmanned landers, this vessel will be returning to Kerbin and has some Kerbals on board to move samples around, so it's a great opportunity to run the Mystery Goo experiment and materials-based study on Minmus's surface for the first time. In addition, we'll bring the experiments we've already ran on Minmus that can be run separately for every biome. These are the thermometer and Geiger counter experiments. Finally, the Kerbals themselves will provide access to 3 experiments: the EVA report, the surface sample, and the crew report, the latter 2 of which are biome-specific again. The end design was this. As you can see, we're making heavy use of the larger rocket parts on essentially every stage of this vessel. The launch stage uses 2 kickback solid rocket boosters and is paired with a liquid-fueled center stage running on an LV TX87 Bobcat twin nozzle engine. The numbers here are pulled from Kerbal Engineer, so it doesn't take into account the throttling of the center engine, which is why Stage 3 doesn't have its own delta V and thrust-to-weight ratio listed. There's also a kicker stage with 3,600 units of liquid propellant as opposed to the 4,500 units in the Stage 3 tanks on launch. This stage makes use of another new part, the 1.875 meter engine plate. This part behaves like a decoupler with the added benefit of allowing us to attach 2 swivel engines together. These 2 stages provide over 4,800 meters per second of delta V, which means that a very minimal amount of the upper stage's fuel should be needed to insert the spacecraft in orbit. If we refer to the delta V map provided with JNSQ, we can see what's needed to land a spacecraft on Minmus. The numbers for the transfers to the Mun and Minmus aren't exactly accurate. For one, we're using a mod that changes the orbit physics in subtle but significant ways. And for 2, Minmus is moved inside the orbit of the Mun in JNSQ if Principia is present in order to avoid the apocalypse. However, the ascent values are still accurate, and from my personal experience, these seem to be round about the real values for transfers and captures. With that in mind, it should take about 2,800 meters per second of delta V to land on Minmus and come back, starting from low Kerbin orbit, and our upper stage here has about 400 meters per second to spare. Once we're finished with our craft, we can warp to a good launch window in the tracking station before moving our vessel out to the launch pad with Valentina and Bob at the controls. It's a launch with a pretty view of the Kerbin sky just before dawn. We did have to end up expending a bit more of the upper stage's fuel than I had anticipated, but we should still be within margin. As soon as the launch was completed, I started planning the Minmus transfer right away to see if I could get away with transferring directly before I even bothered circularizing the orbit. Unlucky this time, so I gave the craft a quick boost at its apoapsis before adjusting the transfer maneuver. The transfer burn went according to plan. No nonsense with worrying about the craft having signal since we have a pilot on board. We have one small correction burn to do en route to Minmus. which will help us come in with a somewhat minimal inclination to save ourselves some pain later. After this correction, we have just over 1500 meters per second of delta V remaining, which is more than enough. Rather than just descend directly to the surface here, I captured the craft in orbit to seek out a good landing site. Since we do have some biome-specific experiments on board, it would be preferable to find a biome that we haven't touched down in thus far. We can use the Kerbalism Science Archive window to see what biomes we've collected temperature and radiation data for, which are the brown basins, brown midlands, and poles. After some perusing of the ScanSat Zoom map, I found a sliver of the non-brown basins biome we're just barely set to fly over. We can burn anti-normal here to move the orbit such that we're flying over a bit wider of a patch of this biome. This is convenient since changes to inclination have their greatest effect 90 degrees ahead of you in the orbit, which is about where we're at. When we're a few minutes from the basins, we do a deorbit burn so that we'll be pretty low but not quite at the ground when we enter flight above the landing area. We're coming in fast and aggressive with this landing. Minmus's low gravity can make it quite fun to land on since the engine you're using is almost certainly going to have a laughable thrust-to-weight ratio. After a very horizontal landing approach, we can enable all of our experiments, and Bob can gain the title of the first Kerbal to set foot on another world. The engine here is quite worn out and doesn't quite have enough burn time left to expend all of our fuel, so before heading back inside, Bob bunny hops over to it and gives it a few good kicks to get it ready for our return home. After that, it's a matter of waiting for the rest of our experiments to be completed, and we can lift off to return home. In the same way you can land on Minmus fast and aggressive, you can leave fast and aggressive. After less than a minute of engine burning at partial throttle, we already have a high enough apoapsis that we can coast out and prepare for the transfer home. Once we're in orbit, the rest of the mission plays out the same as our orbiter mission previously: eject from the moon, retroburn before entering the atmosphere, and pray to whatever god you believe in that you don't disintegrate before you reach the ground. If that wasn't enough foreshadowing for you, this re-entry was extremely dangerous. Last time we just barely got away with it after a fair deal of retroburning, and this time we had less fuel to use for that purpose. This pod was extraordinarily close to its critical temperature, and I had to resort to the age-old KSP strategy of spinning the capsule about like mad to mess with the heating physics. I need to include a better dedicated heat shield, and or use some better command pods in the future to avoid having to deal with this kind of thing. We landed in Kerbin's grasslands, and since we have the science for this biome already, the vessel was immediately recovered. After browsing the mission control, I took a contract to conduct ScanSat surveys of the Mun, as well as a Search the Skies contract for the Research Bodies mod. With 152 science points now available to spend, we are faced with the age-old dilemma of what to put them towards. I've been wanting to save up for advanced electrics for a while now, especially after that fiasco with the Minmus satellite, and we're now only 8 science points away. However, there is a tech we can afford right now that will help with a lot of different missions. Propulsion systems. After we get done with our mission using the big rocket parts we unlocked, we got our hands on small rocket parts. Why? Well, probes and satellites benefit a lot from having these smaller parts available. The next logical administration strategy is the Mun Probes program, which should provide a good opportunity to demonstrate what I'm talking about with the rocket parts. On the types of probes we've sent out thus far, the dry mass of the fuel tank, and especially the engine, have been quite a lot of the overall mass of the craft. Consider the Minmus ScanSat, where I said the functional components had a mass just above 300 kilograms. The Terrier engine used on that had a mass of 500 kilograms alone, alongside the fuel tank with a dry mass of 125 kilograms. This means that about 2/3 of the spacecraft's dry mass was just for its propulsion, which means more fuel is needed to haul that dead weight, in turn requiring more fuel to haul that extra fuel, ultimately resulting in a very bloated spacecraft. The tank on that Minmus probe carried 1 ton of fuel. The probe here has a similar payload to the probes we've sent before, a probe core with some experiments built in, some extra experiments on the outside, supporting equipment, and landing gear. This time, however, we're using these 0.625 meter Oscar B fuel tanks, which each have a dry mass of only 25 kilograms alongside their 200 kilograms of fuel, in comparison to the 125 kilograms and 1,000 kilograms of the FLT 200 fuel tank, the squarish 1.25 meter tank. We're also using the 48-7S Spark engine, a 0.625 meter engine with a mass of 130 kilograms in comparison to the Terrier's 500 kilograms. The end result is that this probe is significantly smaller than pretty much everything we've sent before, and yet has comparable, if not greater, capabilities in terms of delta V. This rocket will be more than capable of landing on the surface of the Mun, which requires approximately 2,800 meters per second of delta V from low Kerbin orbit. Launch windows for the Mun are much nicer than those for Minmus, since the Mun's orbit is not inclined. Once we're in space, the spacecraft is in an ideal position to transfer directly to the Mun without circularizing the orbit. Before the transfer starts, we have almost 4,300 meters per second of delta V available, so this craft is frankly over-engineered for its purpose. As with several of our transfers before, the probe didn't have signal during the maneuver, so a slightly larger correction burn is on the cards. You can see during our correction burn that we're actually relatively close to Minmus. Even though we never cross into Minmus's sphere of influence, it will be affecting our trajectory thanks to the Principia mod. In this case, I think it's probably not particularly helpful or hindering. Our capture burn around the Mun is a bit weird, but it's planned so that the transfer stage can be decoupled to slam into the Mun's surface. It only takes a tiny bit of the lander's fuel to boost it back into a stable orbit for the time being. We want to go one pass around so that we can land on a part of the Mun's surface that's both facing Kerbin and in the Sun. You can see we're still taking the fast and aggressive approach, but due to the Mun's gravity and the higher speeds involved, this is much more dangerous than on Minmus. Since we have plenty of delta V left over, it would behoove me to spend some of it on a slower and more vertical approach. On landing, all of the experiments are enabled and the probe begins to send back some big science points for such a small package. Back in the Space Center, it's time for a quick look back on what we've achieved today. We now have over 100 science points available, but I think it would be best to save up for that advanced electrics tech at the moment. We've completed our monumental goal of setting foot on Minmus, and we've landed our first probe on a brand new body, the larger of Kerbin's 2 moons. Next episode, we'll set to work collecting more intelligence on this mysterious gray fixture in the sky, and see what else may come our way in the pursuit of science. Thanks for watching, and I hope to see you next time.